and we're told that it's given that this formula here, 2ln 4x minus 5 plus ln x plus 1 is equal to 3ln 3, and we've got to show this here. So obviously what we're wanting to do is we want to remove those the natural logarithm function. So what we can do is we can use our log rules to rewrite this. So that my first step would be perhaps to do that squared plus ln, it's a bit messy, isn't it? Plus ln x plus 1 equals ln 3 to the power of 3, or ln 27, using log rules. Next line, using my log rule, I can rewrite this as ln 4x minus 5 all squared bracket x plus 1 equals ln 27. Now I can actually remove those. So I get 4x minus 5 all squared to x plus 1 equals 27. Now I'm going to expand that first bracket, so I get 16x squared minus 20 minus, so minus 40x plus 25 bracket x plus 1 minus 27 equals 0. Now at this point I can expand out again, so I'm going to times everything in that first bracket, so I'm going to times everything here by x, first x, and then by 1, so that's how I'm going to expand that. So I get 16x cubed minus 40x squared plus 25x, now I'm going to times everything by 1, plus 16x squared minus 40x plus 25 minus 27 equals 0. Gather our like terms. So we get 16x cubed, and oh, that should be 40x squared, shouldn't it, actually? Yes. Okay. Now that leads me to negative 24x squared. Now looking at our x's, minus 15x, yes, and then negative 2 equals 0. So there we go. We've proved that. Now, this next question is an algebra question. We've got to factorize what we've just found. So if we factorize it using the factor theorem, so what I'm going to do is I'm going to, in my calculator, I'm going to put this in using my table function mode. So if you go to your table function mode, for me it's number 7, I type this whole thing in. So 16x cubed minus 24x squared minus 15x minus 2. And then it will ask you where you want to start from. I usually start from like minus 4 or something, and then I end at 4, and I'm just going to step up 1 each time. And you just look at your fx values, and if you get, using the factor theorem, if you get a value of 0 for an x value, you know that you've got a factor, or a root, sorry. So when I do this, I find that, let's call this function here, let's call it fx, and I find that f2 is equal to 0, and therefore I know that x minus 2 is a factor. Okay, using the factor theorem, which we've talked about before. So then what I'm going to do is I'm going to use long division to help me here. (16x cubed minus 24x squared minus 15x minus 2). So first of all, I'm going to times everything by 16x squared. And I get, of course, 16x cubed minus 32x squared. I'm going to subtract that, and I end up with positive 6x squared. I'm bringing this minus 15x down. And at that point, I'm going to multiply everything by 6. Sorry, that's not 6x, it's 8x squared, isn't it? I'll just fix that up. Work, please, brain. Okay, so I'm going to times everything by 8. And that will give me 8x squared minus 16x. I'm going to subtract that all, and I'm going to bring this minus 2 down. So I end up with a positive x minus 2, and then obviously I can just times by 1 to get rid of that, and you see indeed there is no remainder. Okay, now what does this actually mean? Okay, well, it means that x minus 2 times 16x squared plus 8 plus 1, that's partially factorized, and then I can factorize this little bit here, and what I actually see when I do that is it's like 4x plus 1 all squared. So I'll factorize completely at that point. Now my next step, it says hence, so this is going back to a logarithmic kind of question, solve that equation. So you can see that there are two answers, x either equals 2 or, looking at this one here, minus 1/4. But it can't actually be 1/4 because if you chucked a negative 1/4 into here, you get ln negative 7, and that's undefined. So we're just going to report our answer as x equals 2. Now, the next one is a trigonometry question, and you can see, hopefully, when you look carefully, you've looked, oh, it's a 2 alpha and an alpha here. So maybe I'll write this as sine 2 alpha, like that, over, now sec alpha is like 1 over cosine alpha, so I can write it like this. Then I can use, for this bit here, I can use this double angle rule here. So in my next line, I might write it as 2 sine alpha cosine alpha all over cosine alpha. And at this point you can see cancel, cancel, and this will leave us with 2 sine alpha. There's a final answer for that one. Okay, the next one here, we've got to find the exact value of cosine b. And I think this time we've got cosine 2 beta here, so we're going to be using the double angle rule for cosine. And since it's all in terms of cosine, I'm going to use this version of the rule here. And then probably I'm going to get a quadratic. So I'm going to go 3 into 2 cosine squared beta plus, minus 1. And then I've got the plus 7 cosine beta on the outside there. And so I can expand the bracket, so I get 6 cosine squared beta minus 3 plus 7 cosine beta. And maybe we could just rewrite it like this, so it looks like a proper quadratic equation. And now we can factorize it. Okay, now what we want here is we want 3 cosine beta, and we want that to times by the positive 3 to get us to 9. And this one is 2 cosine beta, and so we want that one to times by the minus 1, and that will take us back to 7. So we should get cosine beta. Looking at this first one, you can see it's 1/3, third, 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 I want to find dy dt. And I'm going to use the quotient rule here. So if we take this to be u, this to be v, and therefore du dt would be du dx or dy, but I'll just, for ease of following this, I'll write dx. you just differentiate that top bit, so you get 3, and obviously if you differentiate that bottom bit, you get 2. So we can chuck this formula in here. So on the bottom we're going to have the v squared, which is a 2t plus 3. We square that. Then on the top we're going to have the bottom, the v, times the top one differentiated, so 3 into 2t plus 3. And then we subtract the bottom differentiated, which is 2 times the top one. Okay, so I've just followed product rule, and obviously we can simplify that. So I get, well, the t's are going to cancel out there, aren't they? So we're going to just be left with 9 take away 4, which is 5, over 2t plus 3 all squared. Now at this point we can go dy dx is equal to dy dt multiplied by dt dx. So that is equal to 5 over 2t plus 3 all squared. Then we're going to take the reciprocal of this one, which is dx dt. So to get dt dx we just flip it. So we get this. And you can see that that's going to cancel one of those. And so we're going to be left with 5 over 2 into 2t plus 3. So we're almost there. Now, we've got to find the gradient of the curve at the point where it crosses the y-axis. Now, at the y-axis, x equals 0. So what we do now is we look at this here. So 0 equals ln 2t plus 3. Now you know we want to make this ln bit equal to 1, because ln 1 is equal to 0, right? Just remember your basic log rules. So therefore t must be negative 1, because 2 times negative 1 plus 3 is ln 1 there. And then we insert this into here. 5 over 2 into negative 2 plus 3 equals 5 over 2 is our final gradient at the point where it crosses the y-axis. Now let's move on. The two real roots of the equation cosec x into pi minus x in the interval between 0 and pi is denoted by alpha and beta. Okay, so this is part of an exam question. All we have to do today is use the iterative formula x n plus 1 is equal to this. Now, as we did in class, all you need to do is choose your first value. So I'm going to say x 1 equals pi over 2. And then what I'm going to do is I'm going to put pi over 2 on my calculator, go pi over 2, and then press equals. And now that's saved as my answer. Okay, so you can press the orange button. And now you type in the formula that I've shaded in highlighter blue. So make sure you're set to radians, of course, please. 1 plus, and then you, instead of x squared, you type answer squared multiplied by, so answer squared times sine, and then you put answer, close bracket, and then on the bottom of the formula you put pi, and then sine answer, close bracket. So you can see the answer key is next to the equals at the bottom. Once you've got that formula with every x changed to answer in it, then you just press equals once, and that will give you your x2 value. So 1.10, and we're giving to 2 decimal places. Then we press equals again, and this will give us our x3 value. Three, I think. So we're given to 4 decimal places, and then we go x4, and I'm getting 0.7 excuse me, 0.6462. I'm going to go x5, 0.6615, x6, and I get 0.6574, x7, and I get 0.6785, then I get x8. You can see it's getting closer and closer to a stable answer, 0.6582, x9, 0.6583, x10, and I always like to go a few more just to, you really want to make sure that you've got no more change happening, and I see that when I even do x12 I've got it. Okay, better to do a couple more extras and make sure you've done enough to prove it. So we can say it's 0.6622 dp. Okay, and that would be the answer to that. Well, I hope this has been helpful to you. Let me know if you have any questions or want some clarifications. Totally happy to help. God bless team.